So today's class is kind of taking a different, more of a high level view of the energy code and the relationship that it has with design. We've been talking a lot about here as part of the series that we're putting out for 2025. The first week of every month is going to be about plan review and plan review for energy code, and then the second week is going to be that we've kind of picked as the week to talk about inspections, right? How do we inspect for different components? And then the third, fourth week is going to be where we kind of talk about some of these ideas, right? Some of these concepts that we see throughout the code. And this one is going to be that overall approach. Now, and I say it a million times, if I said it once, is, the importance of understanding the why behind a code proposal or code change or the code's development as part of that function of how we're going to actually accomplish it. Today's class is going to bounce a lot about between the residential and the commercial. I know we generally don't talk a whole lot about commercial, but I think it's one of those things where when we think about it in the package, the relationship that exists between the codes, it's a common conversation that you can have for both residential and commercial projects. So this is one of those classes. If you have questions, make sure you raise your hand, put it in the chat, put in the Q&A. It's also a way for me to kind of gauge where we want to take some of these conversations when we get into the more in-depth webinars to come in the next couple months. And so you'll get some ideas. I'm going to sprinkle the idea, and then when we come back and take an actual time to talk about it, we'll get more into it then. But as always, if there is a particular type of construction, right? If there's a particular type of house or building that we should be using as maybe some of our examples, or when we do an in-person training, please let me know so that we can always make sure that our examples make sense for what you're doing. Now, we've tried really hard to incorporate everybody's updates, which is hard to do. So we've kind of taken this, especially since it's more of an overview conversation. We're going to look at it from the 21 perspective. That's kind of where we've been putting a lot of it. You can kind of see where 18 and 15 relate to the energy code, but since a lot of us have gone to the 21 codes, I think it just makes sense to keep it there. When we think about that concept of why do we have building codes? Why is because we want to create that minimum expectations for how buildings are built. Whether, again, we're bridging that conversation between residential and commercial. So any building that's built by a code, residential or commercial, we're really looking at it from this perspective of we want a building to be safe. We want a building that's going to operate at its peak efficiency. Part of safety is understanding our ability to stay in a building and be resilient in different economic or climate times, right? And I think when we understand that why component, we can help better affect those expectations in the building, right? I was in a code development meeting yesterday, and we started to not argue, that's not the right word. We started to talk about the concept of what is a minimum height on a stairway, right? Is it 6'8"? Is it 7 foot? Is it 6'4"? What is it? What does the code say? And why does it say it? And part of the conversation was, well, if a person is walking into their basement and they have a 6'4" ceiling height or a low height stairway, well, they'll know it. They'll hit their head once and they'll be fine. They'll know from now on to duck on the 7th step on the way down into the basement or up into an area. And the reality is, while that makes some sense, it's not the reason why we have a code, why we make that requirement. We make that requirement because we are also thinking, as we see in the very bottom line of our purpose statement that exists both in the residential and the commercial, that we're to provide a reasonable level of safety to firefighters, first responders, right? So we have a ceiling height so that when a firefighter comes in to go and search a building for people during a fire, they're not falling. It's okay if you hit your head and fall, but it's not okay when we send in a firefighter trying to protect lives and he falls. He's already off balance. I was talking to we were having this conversation. He's already off balance a little bit because he's got a tank on his back. He's got a helmet. He's got a mask. It's very difficult to operate. And so he's walking into a house. He shouldn't have to worry about head clearances on new construction or the access paths to habitable spaces. So there's a reason why. It's not just a number we make up and pull out of anywhere. The same thing when it comes to that same consideration. This is not just made up. It comes when we talk about the energy code, right? The energy code is designed to provide us a level of flexibility and innovation when we respond to building a building that uses and conserves energy effectively, right, and efficiently. The numbers don't just get pulled from a hat. They're part of a process designed to kind of project a building that or present or make prepare for a building project that's going to be successful. And there's a lot of different impacts that we see when we think about energy conservation. A lot of it, one of those unwritten understoods is the impact it has on both the individual and the community's financial status, right? If I can better control my energy use, I can reduce my bill, right? If I can control, and as a community, if I can better control energy consumption, I can better utilize my existing infrastructure and grid layout. If we have to keep adding on, and again, I'm having this conversation here locally with my local community in Ohio, it's great. We thought, we've got a nice new subdivision coming in or development. It's not even a subdivision, development coming in. And they want to put in 200 houses. The question was, did anybody tell the utilities? Did anybody tell the sewer department, the water department, the gas, or the electric that this is going on? Or are we going to have a bigger problem as they get these piecemeal one or two, service requests? And then all of a sudden it's like, oh, well, there's 200 houses coming. So you might as well, and it turns into, well, if we had known that, we would have sized the branch line differently, because now we've put in a branch thinking this is one or two houses, and it's going to be 200, so it's undersized. We're going to have to redo all the work that we've done up to this point. And so again, part of that is that conversation about planning and thinking about how we use energy. And we understand in this conversation that we're talking about that the relationship between mixed uses is real, right? There are going to be parts of the building, particularly when we use mixed use buildings, or maybe we have a podium type building where the basement is one type of use and then you have residential on top, which is a desirable way for some people to live and to develop property. But in that situation, there are going to be portions of that building that follow the commercial provisions and portions that follow the residential provisions. And again, we see that all the time in this conversation about how we look at, when we talked about, small scale multifamily, right? When we talked about that class a couple weeks ago, it was, there's going to be some bleed over, but to the same extent, it's still a residential occupancy. And so there's certain things we expect when it comes to residential uses that translate, whether it's 7 stories or it's 2 stories, right? This is how much a normal residence is going to use when it comes to lighting and power. And again, calculating that mechanical load. I was talking to somebody earlier. We were talking about a business, and again, I understand we're not always talking about commercial, but, when you think about mechanical design, right, we want to build a mechanical system that meets the needs of the building. And so if I know that I have a refrigerated building, right, I used to live in a jurisdiction I grew up in where we had a Dole fresh salad processing facility where it was cold by design at all times. And so when you go and design that building and you run it against some of the different expectations in the energy code, we're not doing a comparison that's apples to oranges, right? Or salad to pineapple. No, what we're doing is we're going to compare them equally, right? So we'll talk about some of this probably in the context of the conversation. But if I'm going to if I am designing this building to run at 45 degrees or 50 degrees, then my base standard is going to be 45, 50 degrees, whatever my reference design, my proposed designs are going to be the same. I don't want to use a prescriptive compliance path, and we'll talk more about compliance paths. I might be getting ahead of myself, but a prescriptive compliance path is expecting a certain type of thing, and we need to understand what those expectations are, which is why we're going to take them each individually, section by section, in the coming weeks. Again, digression a little bit. But when we think about the scoping of the code, we understand that commercial provisions apply to anything that's not residential. And the residential we've talked about before are those single and 2-family dwellings, townhouses, and multifamily occupancies, R2s, R3s, R4s, 3 stories and less above grade. So there are going to be projects that we build under the commercial code that fall under the residential provisions of the energy code. And so it's important, again, for us to understand those expectations, which is kind of why the code provides us this list of expected information on our plans, right? We see this in the residential provisions with the recognition of these 9 different items, which again, we talk about consistently, and we'll break these out into different conversations here in the future. But the first one is, again, that compliance path, right? We see that in the 21. In the 15 and the 18, we've got these 9 issues items, these other items listed. In the 21 and moving forward, you see the expectation of compliance path, because that is a fundamental concept that changes how I review this plan for compliance. That changes my inspection protocol when it comes to what am I expecting to see and what level of flexibility am I providing in that design, right? So compliance path is going to be one of those key components, and we'll talk more about compliance paths in the future. But this is really that high level overview conversation. We see it in residential. When we go to the commercial side, like I said, we're going to bounce back and forth a little bit on this today. We see that a very similar list of expectations. It's a little bit more robust because we're talking about a little bit more about different types of mechanical systems, right? We expect a mechanical system in this kind of environment to be a little bit different, but we still see that compliance path is listed. Fenestration, insulation, those envelope components, air barrier, air sealing details, right? The location of that air barrier is all encapsulated, incorporated, because we understand that there are certain fundamental concepts we're going to be dealing with, whether residential or commercial. Again, like we saw in the previous, mechanical systems, and then lighting considerations, right? So again, that's the expectation. And like I said, the primary thing that we want to look for first is always going to be that compliance path, right? We see the compliance paths listed here for the residential. We've got the prescriptive. Remember, that's that tell me what to do, I'll do it. Here's in the table, which again, like I said, if we're dealing with a special type of design, may not be the right solution. Again, if we've got a facility coming in that, let's just pretend we've got a Kalahari or a Great Wolf Lodge, and they've got space that's going to be maintained at a higher than, we know the mechanical code says 68 degrees, right? We have to have passive or active systems to maintain a temperature of 68 degrees. Well, if I know that I'm going to maintain a temperature of 80 because I'm going to put it in this water park, this indoor water park, then I'm not going to compare it prescriptively, right? I want a system that's going to be performing or looking at the level of performance, right? Again, if I know that I'm going to just use the example, if I'm going to put a sauna in my house, which would not be something I would do, but if I did, I would want to know that it was designed and installed as a sauna, right? Not as just a room that we put a lot of heat in and then just let it naturally, mess up the walls and allow for condensation, allow for all the negative impacts, right? I want to make sure it's properly sealed, properly installed. You think about that again. We don't just put a drain in the middle of the floor in the bathroom and say, we're good. We require the waterproofing. We require the tile to again, control moisture accumulation and water movement, water flow, right? So there are certain considerations that we think about. And again, that decision on how we're going to comply really is important for us to understand. If we're doing that total building performance, again, I use this example, this symbol, because it's all about the money, right? It's all about how much does it cost to operate in a given year, right? It gives it a standard amount of time. You run it through the calculations and you get it. Now, next week, I'm going to go to a conference in Arizona where I'm going to be talking to some of the different companies that do these analysis. I know we've been talking about maybe having a presentation or a discussion about how these systems actually do that energy modeling. So I'm hoping after that conversation, we'll either be able to have one of them come in and do it, or again, we'll have the adequate examples to really dive into what does compliance really look like, and how hard is it to get to, or how hard is it to do as a method of evaluation, right? As a compliance option. And then we also have the ERI, the energy rating. Again, similar to what we call the HERS, or maybe an Energy Star conversation. I'm going to talk to Energy Star next week too. But again, that's all about maybe not the dollars and cents, but some other rating, some other calculation, quantitative calculation that says this is how the building performs in comparison to a design, a reference standard. Those same 3 concepts are really encapsulated in what we see in the commercial code, right? We see the prescriptive compliance. We see the total building performance. We get ASHRAE 90.1, which is a different standard. The ICC says, hey, use us, use them, use somebody to make sure we, have that flexibility. You want to use their calculations, go for it, right? Because what you're going to see, if you go to the ASHRAE standard, you're going to find out that they have a prescriptive requirement. They have an energy cost budget analysis, and they have a performance rating, right? So you have that same level of flexibility in residential and in commercial. So again, it makes it a little easy for us to see when we start to grab, it's well, do I change my mindset from residential to commercial? In my opinion, no. It's just a scale, right? You're still expecting the same things. Show me the compliance path. I know they're going to be very similar. What am I expecting to see, right? When I look for compliance under the energy code, I'm looking for, the envelope, right? We talk about these 4 key components, these 4 key pillars of our building design. We see that in the envelope, the mechanical systems, and the power and lighting requirements, residentially and commercially, right? Commercially, we see it separated a little bit more in that building mechanical, which is going to be our space conditioning versus surface water heating systems. But then again, we get back into the electrical power and lighting expectations. And again, remember, we're going to have times when maybe we have a multifamily that's going to be treated different than a traditional single-family residential home when it comes to those lighting expectations. And one way to really think about that is when you think about exterior parking areas, right? That obviously you're going to have parking areas that are going to be different in a multifamily than you see in a single-family home. Now, depending on where you live and what part of town you're in, you might think they're the same, right? And if they're like the I made fun of our neighbors. And I thought, well, wait a minute, we're going to be there soon too. Our neighbors a couple years ago, it was 1 or 2 cars in the driveway, and then it became 5. All of a sudden, like all the kids were driving in the neighborhood. And it's like, oh man, there's a lot of cars over there. And I thought about it. I thought, oh man, here in a couple of years, I'm going to have 4 kids with 4 cars. I'm going to need a bigger driveway. I'm going to look like I'm having a yard sale or something. So again, we start to think about these systems a little bit different, but the same concepts, right? Envelope, mechanical, surface water heating systems, and power or lighting. And these are, again, the fundamental concepts of pillars. I call the pillars of energy code compliance. And whether we look at it, again, the same concept, just 2 different sides of the same coin. When we're looking at that building thermal envelope, again, we're looking for the envelope, right? What is it that separates our exterior environment from our interior spaces? And in the commercial, it's going to be that we'll see here, it's the walls, the opaque portions of the walls that provide thermal resistance, the roof, the windows or fenestration, and the air barrier. When we go and look at that from the perspective of the residential code, we see the same concepts, right? And so both codes recognize that there are going to be buildings that might use less energy. And so because they use less energy, if they meet a certain level of energy usage, which is down here, this 1 watt per square foot for space conditioning purposes, then they don't have to follow the expectations associated with the envelope. Because what is the envelope doing? The envelope doesn't use energy. The envelope is there to provide control over our space conditioning service systems. And so if it's got that level of control, then we have to have, if we're using a specific amount of energy, then we need to control it. And this allows us, again, greater flexibility to say, hey, if we're not using energy, if we don't have mechanical systems, then we don't need to worry about the envelope. Not every building has to have an envelope consideration. As well as, so we see that both with the size of the space conditioning or when there's no conditioning. And again, log homes. If we have a home that's built, I've not seen a lot of those out there, but the moment we all say that we don't have them, that's when somebody's going to build one, right? Same concept. We talk about those steel frame structures, right? Not steel frame, those container homes that we've talked about a few times, right? As soon as we say we don't do it, that's when somebody's going to show up and do one. But again, that same consideration goes over into the commercial, right? That same 1 watt per square foot, that same, if it's not conditioned, don't worry about the envelope, right? Again, if we've got operations that are maybe greenhouses that we see here also identified, we're not thinking about it in that, we're changing the consideration, the why of the energy code. And so we'll dive more into this as we go through the next couple weeks of trainings. Same thing for equipment rooms. If we've got a design that incorporates a mechanical room or mechanical building that isn't designed for occupancy, then we're not going to consider it the same way we consider occupied space, right? Habitable condition, occupiable space is what we're trying to protect and ensure that when we heat and cool that space, in a mechanical room or in an equipment room, we might be maintaining a small set of heating units in order to keep things from freezing, from becoming completely unattainable. But at the same time, we're not conditioning it for that expectation. So there are going to be certain allowances in those situations for what it can be exempt from. All right. We understand that, again, when we look at this from the envelope's perspective, that envelope is what we're looking for to address thermal heat loss, uncontrolled heat loss, right? We've talked about this, and when we talk about it more in the next couple of weeks, this is that you weren't born in a barn yesterday concept, right? We need to make sure that we control it. I always get frustrated when we find out there is uncontrolled heat loss. I took my daughter over to a school function last night, and somehow I find my way meandering over to the maintenance guy. And I said, "Hey, how's it going?" I think it was because he's bald, and I always start off with the same. "So how's your barber?" Right? "Where'd you go?" "Oh, same barber." Yeah. So, right? That's my little joke of the day. But I was talking to him and then asking how his day was going, how his week was going, and all that with the snow and everything. He's like, "Yeah, I was up there painting ceiling tiles." I said, "You were painting ceiling tiles?" "Yeah, we get every once in a while around this time of year, we start getting water leaking. And so we have to go up and paint the ceiling tiles so you don't notice it." And I kind of had that look on my face that must have said, "What?" Because he said, "Why? What you got that face for?" And I said, "Well, do you ever go up there and actually see why it's leaking? Is it the roof? Is it the condensation on pipes because it's not properly insulated? Is it, did you, we don't really look for it. We just go up there and paint it real quick with some spray paint, and then we just leak." I said, "How bad is the leak?" "Well, we cover it with spray paint, so we don't know. It's just real quick. We just want to make sure it looks good." You're killing me, right? You're killing me because you're killing me, Smalls. You got to find out why it's leaking, right? Because otherwise, all we're having in that ceiling tile is going to be just mold. We're going to have a health issue for the kids, for the occupants, for the people that have asthma and other, respiratory related illnesses. You have to find the problem. Part of that is understanding this concept of the thermal envelope. It does no good to have a mechanical system if we just allow holes like Swiss cheese and the air just moves out. Anytime we pressurize the building, all the heated air that we spend all that money making or cooled air goes out the windows, out the doors, out the wall, out the receptacle plates, because it just goes right behind it and out the space, right? That's all considered when we start thinking about how we design our thermal envelope, both in a residential and a commercial consideration. Not only do we think about how we calculate the thermal resistance values, right? Those R values, U values, R factors, and R values and U factors. We also consider the method of installation, right? The component. We know the code addresses, the installation of insulation in these different specific assemblies and design components. That's both for residential and for commercial. So again, that same expectation that I see for slab it what am I thinking? The word I'm looking for. Wall insulation, right? When we come to a rim joist or a header, right? Those same considerations I put in residential, I should have in commercial, right? I want to protect air transfer, heat transfer through these assemblies. And these assemblies are going to be the same place that we see heat loss and air loss all the time. I think I made a point last week when we were doing our training. I was doing a mechanical class in the state of Minnesota, and I took the team. I said, "Hey guys, let's go for a walk, right? We're going to go out and look and see how our mechanical design is impacted by the environment, right?" So we went upstairs, and I brought the little thermal gun, and I showed them as we're standing there in this conference center. And you can see the impact of the cold weather on the glass, on the exterior components of that exterior envelope, where you can see some areas that have visible heat loss, right? You can see the temperature differences, right? We have thermal bridging going on. We have heat loss going on. We have, all the conductive components there affecting that space, right? And so we have to consider those things in the process. And part of that is through identifying the appropriate type of insulation, the appropriate type of sealing, going and holding those values against what we see in the tables provided in the code as part of our prescriptive compliance, or we're going with one of those alternative compliance methods that includes something like a COM check, which is again that mathematical calculation for the entire area weighted average, or the res check that we see in residential, right? We have all these options, which is why when we get into this conversation, we'll take each one of those a little deeper. What does a res check look like? How do we get it? Why do we get it? How do we use that and see that building thermal envelope in relation to, our fenestration, right? Most walls don't just have walls. Now, there are some that are going to have very small, if no, maybe even no windows. But for the most part, we have to consider that there are going to be windows and doors in a building, and those are going to be breaks in our continuous thermal envelope. And so how do they perform? What are their U factors and solar heat gain coefficients, their heat loss and heat gain, right? Calculations. And so we want to make sure that it's not just something left to chance as a last minute, hey, throw in number 10 and give me a couple of U factors, right? When we're doing a project, we want to make sure from design to the plan review to the installation and into the inspection process that we're all on the same page when it comes to what we're expecting to see in the field. And so if I've got a house I'm running and I see these are the windows, I want to know, not only do we have 1 inch of clear insulated glass, what is my thermal rating? And was it calculated at some point in the heating and cooling requirements of the building? We know there are beautiful homes, beautiful landscapes people might be looking at. And so they may have more windows in one area than another. And so those windows may need to be specifically designed to resist unintended. Again, if you want that solar heat gain, go for it. But if you don't, but you want to make sure you know what you're controlling for. That you in the design process, not you as individuals, but as the designer goes through the process of making sure they properly size the equipment to meet the demands of the house or commercial building, that they know how much heat gain they're going to get from the windows, right? And the walls. Same concept with our commercial, right? We're looking at not only the fenestration, but also the roof solar reflectance. We understand that the roof in certain climate zones, which again, maybe not so much there in the panhandle, but again, in certain climate zones, it can have an effect. And so the code doesn't say you can't calculate it, but it does say it knows that in certain climate zones, that's going to have a greater effect on heating and cooling. Not in us, not in the Amarillo area. But again, how does that impact heating, cooling designs? When do we need to install, again, skylights as part of the code? Because again, that skylight is performing a couple different things. One, it may be giving us thermal, natural heating, but it also provides us natural lighting. And we'll talk more about lighting at the end. We'll talk about those commercial operations, or maybe even some buildings that utilize skylights, and what are our expectations of those skylights in relation to our building thermal envelope. They are part of the envelope, so we need to make sure it's part of our consideration. That envelope is only as good, right? We know that the insulation in and of itself is not the end of the process, that it's part of the process. And so insulation slows the conduction of heat through a material, and it's also but how does it get there, right? It gets there because air moves, right? Air moves from areas of highest pressure to lowest pressure, and so it tries to push through the building from the interior space out into the homeostasis outside, right? Air is constantly trying to push out. Now we can design a system, whether that's a whole house mechanical system, to be positive or negative pressure supply versus exhaust, balance systems, all those kind of considerations. But ultimately, that's based on an awareness or a recognition that we know the air leakage rate of the building, right? The code gives us a variety of different expectations for that air leakage, right? It gives us table 402.411 that tells us what to expect when it comes to the installation of insulation and air barrier materials in certain components, like we said, with rim joists and walls and things like that. It also gives us this expectation about what is an acceptable level of air leakage. We understand things leak. I mean, if we go to the store and we buy a brand new Mylar balloon, right? It's a metal balloon filled with gas. Eventually, that gas is going to dissipate and leak out, right? The rate at which it leaks out is almost like a weird science to me, right? But it's the same way we think about air leaks out of balloons, air leaks out of buildings, but it's a question of how much is it leaking, and is it within a level of control, right? We have an expectation, and again, I think one of those things we talked about at the very beginning. What is that expectation? What is, and again, I am 100% a believer in the local control over some of the code development process, as long as we understand why we do something, right? If we want to adopt a code and then remove a section, why? As long as we, one of the things that we've talked about, I know, and I don't make this sound, you guys know my thoughts on this. We have an exception for the heavy termite area, for the slab insulation. Why? Because we have a problem with termites, right? It's not that we didn't have a reason, right? We have a reason, and so that's the response. There's when we look at alternative means and methods of compliance, right? When we determine that we're going to do something completely off book, why? It's because it meets the intent of the code. We've evaluated it. The building official, the plans examiner, that process is there to say, well, this is a little unique. We're going to go with this alternative, and it meets the intent and purpose of the code. We're good. It's not this willy-nilly thrown out, like, hey, whatever you want to do, go for it. I'm dealing with a community currently that their last code update, because they don't live under a statewide code, their last update was 1998, right? They got the SBBCI, I think it's SBBCI, SBCCI, but it's a 98 building code. It's like, you guys know it's been 30 years of technological and material advancements. Changes, not always advancements even, right? It's changed in the last 30 years. And so the materials that you're prescribing may not be effective anymore. Well, we just allow it as an alternative means if they do something new. Okay, but are you okay, right? Part of the reason we update codes is because we know new materials come online, and we shouldn't have to treat everything like it's an exception, right? If we were adopting, and again, I know we've just adopted the 21s last year, in the last year. It might have been the beginning of last year. Anyhow, we know that the 21 code was discussed and gone through and went through the plan. The changes that take place in the 21 from the 2018 took place back in 2020, 2019, 2020, right? So today they're 5 years old minimum, right? That's the changed portions. The older portions are even older than that. We're not changing the future of, or what we expect buildings to do in the future. I know a lot of the builders up there love to go to the builder show. They're not going there to find out what's the old things in town. They're finding the new things to put in, right? They find the new way to put rock wool or mineral wool or some new way to apply spray foam. They're not going up there and saying, "Hey, how do?" When I go to the builders convention, I am not asking, so where's the asbestos containing materials? Because I want the 1970s style. Can I get some 70s vermiculite back? No, that's not what we're doing. We're looking for new materials, right? And so, again, codes develop with those understandings. Digression, don't get me started. But again, we understand that the role of the air leakage is also to protect, again, how effective our equipment works. when it comes to these different systems. And those same expectations pull over into the commercial side as well, right? Whether we're talking about properly installing the air barrier, and then what are those expectations for inspection, right? If we read what the code tells us, we have an option of complying with 5.1 through 11 or testing, right? If we follow 1 through 11, it tells us we need to identify the air barrier, install the air barrier, think about penetrations and ceilings, make sure we pay attention to compliance with the opaque portions, right? And then it gives us a list of materials that we can utilize to be part of that system. It gives us verification and inspection expectations. So we can say, hey, we did it, this is what we used, we verified this was installed properly, it was sealed properly, we did everything we needed to do, now we're good. You can do all that, or again, and including these other considerations for fenestrations, doors, chutes, exhausts, vestibules, all that stuff. Or we can go with testing, right? It gives us flexibility. We don't have to wait for somebody from Lubbock to drive up. The code says we have some flexibility. If we install it right, we use the right materials, and we do it right, then our buildings will be airtight to the level they need to be, right? We know when I buy a car, right? When I bought my car, I knew that based on certain expectations of internal quality control, I did not need to take it to a secondary third party to say, hey, does the heater still work in my car? No. One, I can tell because when I turn it on, it either gets warm or it doesn't, right? If the heating core is connected to the distribution vents inside the car, it's going to work. I know it's going to work. But if I want to check the efficiency, I have a level of quality control that I get through the inspection process, right? We've talked about, it's been a long time since I've referred back to my pants and the little tag that's inside the pocket of your brand new pair of dress slacks that says inspected by H or R or 7, right? Some guy, somebody somewhere is out there looking at those pants saying, yep, those still work. And so I trust those pants. And so we can have that same level of trust in our contractors as long as we know they're following some quality control components or considerations that we see identified here in section 402.511 or 1 through 11. I'm gonna stop there and keep going, because if I don't, I could talk about this for an hour, which we will later, right? But again, what are those expectations on air leakage rates, the testing expectations? All those things will be things that we come back and talk about. Where do we use, again, visual tracer, smoke tracers, and infrared thermal imaging so that we can say, we verified the system works. Here's how we can check it. So again, those things exist. Whether we're talking about commercial mechanical systems or residential mechanical systems, both within the 15, 18, and the 21, we understand that mechanical is a huge component of compliance, of energy code compliance. There is no energy going into the drywall. There is no energy going into most windows and doors, right? The energy consumption that we see every day, day in, day out, is related to our lighting systems and our mechanical systems. Now we see in the code that we address both mechanical systems for heat, for space conditioning, as well as our service hot water systems. Again, in residential, it's one section. In the commercial, it's two different sections. But again, we're treating them, they're basically the same considerations. I taught a class, we could teach a class tomorrow on mechanical code, and the mechanical code is going to match almost word for word the expectations, or procedurally the same expectations we see with mechanical systems in the energy code, right? We expect, both in the mechanical code and in the energy code, that we evaluate the building's needs, right? That we do this manual J calculation or a mechanical load calculation for commercial to say this is the heating and cooling requirements in the building. Now, we can do heating only, but if we're going to have cooling equipment, we need to make sure it's sized. And 9 times out of 10, a system's going to do both. But we're just going to go with whatever the required expectations are for the design for the equipment. We want to make sure it's sized to meet that. That comes straight out of whether we're getting that from 1505 in the IRC, or we're getting that from section 3 of the IMC, or I think it's 4 for the UMC, right? what we're expecting is that they have calculated a design based on the occupancy size, the level of occupancy, the level of activity, and the thermal envelope design, right? How much latent insensible heat loads are we going to get from this potential project? And so they're going to make that calculation, say this is the right piece of equipment. And then they're going to do this thing called sizing, right? You figured out this will work. Now we properly size it. That's where we, in residential terms, we go to this concept of the manual S, right? We're expecting, again, that not only did you identify a load, but you made sure the equipment meets that load. And we also find that identified again we use in our residential side the manual D, right? The duct distribution and design concept. We want to know what size duct is going to transmit the amount of air I need it to that room, right? Again, things that are required by the mechanical code, we're just double checking here in the energy code to say, hey, are we making sure they did it, right? Thinking about it from a commercial side, again, it's the same concept. What is the system designed to do? And is it meeting that required amount of heating and cooling load, right? And then the only thing that the energy code really throws on top of the mechanical requirements for residential and commercial is that we've got some concept of equipment efficiency, right? Again, how old are these numbers? 7 years old in some instances, right? We know they're not just by the energy code, they're also by federal statute in most situations, right? So again, we're saying you got the right size equipment, you have the right efficiency for that equipment, you pick the right brand, it tells you right there. The code says I need an 80% efficient heating system, and you go to the supplier and they says, we got a 92 is the lowest we've got. Well, 92 is way better than 80, so it then complies. Same concept here based on, again, our different calculations of seasonal efficiency ratings or coefficients of performance if we're looking at maybe a heat pump. Whatever we're looking for, there's a table that says, hey, is this, not only did it meet the load, is it efficient? And again, that's something we see in the mechanical code, except for that efficiency component. We know that the code identifies for us some things that may need to be commissioned. Again, if we're talking about a system that serves multiple zones, or a large house, then you might want to have a commissioning system. I think back to that system we saw, the RIA system over in the southwest side of town. Joel, if you guys remember from last year, we talked about Joel's RIA system in that house over there. That's the kind of system I would want to have commissioned, right? Even in a residential application, I want to make sure it's installed right, that I'm getting the right airflows where I'm supposed to be getting them. Not just, I put the duct there, I put a duct and I stopped. No, we want to make sure it's done right. Certain types of equipment, especially in mechanical systems, are going to have that commissioning so that we, again, have that level of confidence that it's going to effectively use energy. Whether we look at the residential or the commercial code or the mechanical code, residential energy, commercial energy, or the mechanical code, there's an expectation that if we have mechanical equipment, then we have to have controls. Now, maybe they get a little bit more in depth here in the commercial code, in the expectations for those systems and how they turn on and turn off, shut down, start up based on schedules and occupancy expectations. But you have the same thing when we look back to the controls associated with, our residential. We have to have a control. The only thing the energy code says is it should be programmable. It should be programmable. Whether grandma or knows how to use it, or grandpa knows how to use it because they can't get the VCR to work. Are they going to be able to work this? Maybe not. But at least we provided them that level of control over their environment. I know my in-laws, they have no clue how the thing works, right? They turn it on, they leave it the way it is. But again, they have the ability to control it. They may not choose to exercise that control. The code goes in different sections of the mechanical provisions for both residential and commercial. We'll talk more about this when we do mechanical plan review, inspection, and design. But it gets into certain types of equipment. And really what it tells us is more about the expectations of those equipment when we have them, right? When do we have to have, or what are those expectations of different things like economizers and dedicated outdoor air systems, variable air volume devices. When do they come into play, and when we use them, what are the expectations? Again, the code's less about telling us directly do this as much as if you're doing this, this is what the expectation of that system should be. Again, same thing with exhaust and ventilation. Remember, when we talk about mechanical design, we're talking about a system that doesn't just heat and cool, but also maybe providing, ventilation air, exhaust air into or combustion air, depending on the design. So again, where do all these pipes go? And I know this, we talked about this before. I always find it funny that, when I get my small residential plan, it'll always have listed on it where the electrical receptacles are going to be, where the light switch and the ceiling fan might be. Those conduits, those cables, those wires are the diameter of my finger, right? But when it comes to the sewer, the septic line, maybe a 3-inch, 4-inch, whatever, depending on what size you're doing. Okay, that's listed sometimes, most of the times. But when we start talking about this 6-inch, 8-inch duct, everybody thinks, we don't need to tell anybody where it's at. It'll show up. It'll just be put right. No, it's important that we know from the beginning. Where is this exhaust system, this ventilation system, going to go in the wall system? So I don't put a secondary trade in there, and then I can't use it now because I can't get around that electrical line. I can't get around this, that, or the other, right? It's the biggest size piece of equipment that we're shoving through the wall system. We should know where it's going to go. I'm just throwing it out there. And that's one of the expectations of the code, that we think about design, we think about distribution, we think about construction, right? Again, the construction of that HVAC system is important in both commercial and residential, right? The mechanical code tells us that we need to insulate. What the energy code says is actually we're giving you more flexibility. If you install it within inside the building thermal envelope, you don't have to insulate as much. Because again, we're trying to ensure that we have adequate protections against condensation more than we are thinking that somehow we're going to retemper the air mid-flow, right? We want to make sure that and those are considerations that we'll review when we talk about inspections. But again, what are those systems expecting to do? How are we testing at both the rough end and at the post-construction? And then what are the expectations for air leakage? Right? We allow for a level of duct leakage. I've seen tests that have come back with no leakage, right? Because they've taken the time to install it properly. They've thought about where it would go, and they don't have pinch points, and they don't have tears because some other function or feature came in and was put on top or ripped through it, right? Especially with flex duct, I see all the time where we got little rips and tears in the lining, and then we've got a little bit of air loss. Well, that air loss is ultimately, depending on its location, which is why we think about it in the energy code, is going to lead to moisture accumulation, condensation, other bad things, right? And so those are things that we consider in energy code compliance that again are reinforcing what we're expecting to see in buildings. Same thing when it comes to plumbing, service hot water systems, right? We're thinking about how do we insulate, how do we protect that pipe, not because we're retempering the water as it passes through, but so that we can take the chill off the pipe to prevent sweating, but also to prevent unintentional, uncontrolled retempering of water in a storage tank, right? We want that heat trap for a reason, because we want to prevent water sitting in the line all day to make its way back into the tank and require retempering. Again, if I'm not going to be home for, if I leave the house at 8 a.m. and don't come back till 6 or 5 p.m., I don't need this water tank working constantly. No one is going to be home. There's no demand. There's no need for it to work. And again, we see that a lot more obviously in the commercial side of the conversation. But again, you're starting to see it. At least I'm starting to see it in some of these new designs for residential. If I don't need the system, I don't need to run. Now, where that drives me is also this conversation about, remember, if I have a gas-fired, 40-gallon, service water heating system that's coming in at 40,000 BTU, and my wife decides tomorrow, hey, I want to get one of them instant hots, those little, on-demand hot systems, heating systems. I need to not only make sure that it's plumbed properly, but I also need to check to make sure that I have adequate gas pressure, right? That the line servicing it is capable of supporting it. That the meter is capable of meeting the demand. If I'm going from 40,000 BTUs to 200,000 BTUs, which is a very easy jump when you think about those systems, I've seen some even in the 300,000 to 400,000. That pipe was not designed to carry that much gas, right? So I need to make sure I think about that, and I check my meter. Because my meter may not have been designed to handle that kind of flow, and I'm potentially creating bigger safety problems for everybody involved. And the code addresses not just the surface water heating systems, but it also addresses this concept. Again, here's the heat traps within the expectations. Here's the heat trap associated with, again, the commercial layout, but also uses this concept of how do we protect it, right? Do we insulate? Do we put heat tracing around it, right? You can either insulate or you can heat trace. So again, maintain the temperature of the line in relation so that we don't create condensation. Again, recirculation pumps and those kinds of things. When we have snow melt system, which I know is not probably a big thing out in Amarillo, right? I get that. But if we do have hydronic heating and cooling systems, we need to think about how they're installed. That's all I'm going to say on that, and then I'll move on. I know we do have pools. And so if we have outdoor heated pools, there's certain expectations as far as the residential and commercial code come when it comes to how we heat those and how we protect against unintentional heat loss due to covers, right? Do we have timer switches? Do we have controls on those heaters so that if I'm not there and no one's using it, it's not on all day, right? In the middle of summer when it's 107 degrees, do I still need the pool heater on? No. Maybe when it gets cold, I might turn it on just because I want to be able to, to go out there and think about those considerations. But I don't need to have it on all the time. I need to have some level of control to monitor my energy consumption. Now, if I want to get away from this, that means I have to think about how I'm heating. How am I providing power to that heating and cooling system? But again, that's a whole other conversation. Electrical, this is one that usually drives a lot of conversations, at least with new code, beginning in the 21. In the 21, you see a lot of, in the residential provisions, you see a lot of black bars, right? Those black bars represent code changes, right? And so really what we've seen shift primarily is the concept that we went from, just control a couple lights to how do we control the lights, right? Just replace the lights to how do we control them? So in the progression of time, we've seen it go from 75% of lamps have to be high efficacy bulbs to 90 to 100%. And then the concept of maintaining or controlling for fuel gas lighting systems with a non-continuously burning pilot light has been the same, right? So we've had a slow escalation of expansion of the concept of more lights have to be efficient. More lights are efficient. And again, this concept that if we have gas lighting, it's just not continuously burning. That stays the same. Where we start to add in the new parts of the code is when we start talking about exterior lighting, right? When we start talking, again, remember, we're exempting detached 1 and 2 family dwellings. So we're talking about, do we have parking lots, right? If we're talking about some of those residential spaces, where we might have a multifamily and we've got parking spaces. So that's where we're talking a lot about the exterior lighting. There are a variety of different ways to evaluate it. We'll talk about that in a little bit more detail when we get to exterior lighting because it's a whole separate conversation when we think about it. Interior lighting, what we're talking about is how do we control the lighting inside the building. For the most part, we're either putting in a dimmer or an occupancy switch, right, into certain rooms of the building. Now, you guys know I have been loving my occupancy sensor in Felicity's room because since I put that thing in there, a year and a half now, she loves it. She doesn't even touch. She doesn't have to worry about turning the light off anymore, right? When she's in there dancing, playing, doing whatever she's doing with her friends and pretending and drive me crazy with the makeup now, her lights are on. When she wants to watch TV in her room, because we put a TV in there, she can turn it off. But exactly, it's a time saver for her. She doesn't have to worry about, did I turn my light off? No, it turned itself off, right? It's not only a financial gain, it's a time saving, and it's one of those things. But again, we're seeing more and more come into buildings, especially with the code, right? Have a dimmer, have an occupancy switch. And again, the same way we knew in our plans 10 years ago that this is where the switch is going to go, now all we're changing is what kind of switch am I looking for? Does it have a dimmer? The reality is we all used to complain about things being super expensive in relation to other items, right? It used to be, and I had this conversation with my son yesterday, when we bought our first 27-inch TV back in 2003, it was expensive. We bought our first 50-inch TV, flat screen TV, about 10 years ago now almost. It was expensive. Now you can go buy a 65-inch TV at Walmart for $290, right? When I bought our 65-inch, which just went out, that's why we're having this conversation, it was $800, right? You guys remember when TVs used to be expensive. Why did they reduce in price? Because they became more regular. They became more of an accepted item in everyday homes. Same concept, I'm guaranteeing, same concept when it comes to this idea of the dimmers and the switches. It's going to become normal. I remember when we were doing some electrical work, dealing with a contractor, it was cheaper to buy a three-prong receptacle than it was to buy a pack of two-prong receptacles, of non-grounded receptacles. It was cheaper because they know that the code is out there. They know what the expectation is. And Lowe's is going to stop carrying things that they can't sell, right? They're just going to, and they know that. And so again, prices go down as time goes by. And so we have occupancy sensors that exist. Where they exist, the code again provides us. We'll talk more about them when we need to have those motion versus dimmer switches, again, covered by the code, addressed by the design. Now we need to make sure it happens. Same thing for the outside. Same thing when it comes to residential or commercial, right? Same consideration. Now remember, there's going to be times we're talking about dwelling units in those commercials, especially those over 3 stories. And so in those, where are we expecting to see those? What are those wattages per light, right? But again, we have those same considerations for how we deal with lighting and sleeping units, right? Now, I'm not going to get into a big, deep conversation at this point about it, but we know there are methods for controlling lamps and lights, and that's going to be through switches. And the code addresses a lot of switches in their layouts, as well as side light, top light, daylight responsive controls. Because again, we're looking for, if we've got lights on and the sun is out and it's giving me natural light, I don't need to turn the lights on. And so how does that system control itself over time? And so what am I looking for in a plan? What am I looking for in the field to make sure I know what those expectations are going to be? The code gives us some, again, recognizes the relationship with the CommCheck, ResCheck, some of those different systems for identifying our interior and exterior lighting requirements, as well as some of the different types of equipment that might require, again, if we're looking at hotels, motels, different dormitories or spaces that have elevators installed in them, then what are our expectations for those structures in that compliance process? Like I said, I'm going to be at the team at the conference next week. I'm going to be talking to some of the people that do these total building performance softwares, so we can have a conversation about that. But I think one of the things to really hit on is, again, we have these options, and I don't have time to go through this example. I had an example here where we're going to go through and look at a school building that was being built. But again, it's a simple process. It's the same process that we would use for a residential. It's just more in depth because of the nature of what it is. So I know it's a lot of information. It's a high overview of conversation. We're going to dive more into each component in a more intentional way in beginning next month. But if you have questions, always feel free to reach out to us. Send me an email. Again, next week is Bring Your Energy Code Questions. So we're going to have the entire team. Gil's going to be here. Hope will be here. Andre and myself will all be here for this conversation to see, is there something that we can answer questions you've sent, Question weeks get every week when we're doing stuff around the country. And then we'll get back into this. Remember, first week of the month, always plan review, at least for the first couple months through June. First week of the month is plan review. Second week is inspections. And then the third and fourth week, we'll get into these little more in-depth conversations about design considerations. What's the code doing? Or maybe some weird things like entrances. How do we do with vestibules? So again, I appreciate you guys. When you exit, you're going to take your survey. If you have questions, comments, if there's something we need to start talking about, please let us know. We do a lot of residential because there's just not been a whole lot of push for commercial. So if we need more information, please let us, we need to hear from you what you need to hear from us to have that. So I think it's going to be a good breakout, for the method of doing that. Again, we've got the website. You guys should have it. If not, I'm going to be sending you a copy of all of the newsletter. Again, I am going to go through today and send out the CEUs as soon as I hang up with you guys. So if you have any questions, feel free to send Hope or I an email. And again, like I said, we're looking for sometime in March to maybe be out for a couple of days of training. So you guys have a great week. Be careful, be safe, and I will see you next time.